Hi, welcome to the next chapter. Today we will discuss the chapter circles. It's a very simple chapter and a small chapter with two basic theorems or concepts to be acquired and certain questions based on this. Just like our previous chapters on geometry, we will first explore the reader as such, and after finishing the reader, we may go for additional questions. Questions outside the reader, but you need to expect questions directly from the reader this time. Okay, so let us come to the chapter. In this chapter, we will be basically discussing the relationship between a circle and straight lines. You know that, like all of us know that, like, what is a circle? Circle is just a collection of points which is equidistant, which is lying at a common distance, set of all points which is lying at a common distance from a fixed point. That fixed point is known as center. We know that, center. And the constant distance is known as the radius. We have discussed all those things in the smaller classes. So there is no one who don't know what is a center and a radius. I mean, circle means just nothing but collection of points which is lying at a what? A constant distance. All those points which is lying at a constant distance. That distance is known as the radius of a circle. Now, let us consider a circle and straight lines. I'll put 2 or 3 figures here. So let's consider a circle. I've just drawn 3 circles. I'm just gonna draw straight lines along with these circles. The concept is nothing but what is the relationship between, or what are the possibilities that can happen or that can be seen when we examine a circle and a straight line. So let us see. I'm just going to draw certain straight lines here. So a straight line can pass, and circle and a straight line can have such a condition, that is, a circle may be there and a straight line may be there. Does it intersect? Or in this case, a circle and a straight line can pass like this. That means the circle intersect, or the straight line, circle and the straight line intersect at 2 distinct points. And last but not least, there can be a case like this, where the line intersect the circle exactly at 3 points. That means here there is no intersection. Here there are two points of intersection, 2 points where the circle and the straight line intersect. In this case, it intersects at exactly 1 point. So we make a difference between these two. That means in this case, we say that the line is called, what do you call that? Line is called a secant to the circle. It is known as a secant to a circle, and in this case, it is called a what do you call it? Tangent. So what is a tangent? So tangent is nothing but a straight line which intersects, or which touches a circle exactly, or intersect a circle exactly at 1 point. What is a secant? It's a straight line which intersects the circle at 2 distinct points. So it's not only secants can be drawn for all different types of curves, not only for circles. Different figures we can draw secants. We will discuss that in the higher classes as we come across that. So tangent is a straight line which intersects the circle exactly at 1 point. Now the question arises, can I draw one more tangent to this circle? So consider as tangent here. I'm just having a tangent here. It's a tangent going. Okay. So straight line, just a little bit bent. Is it possible to have one more tangent there? If I try to draw one more tangent, no, it will intersect the circle at, one more point. So it's not a tangent, it's actually secant. So in short, you can have only one tangent to a circle at a point on the circle. Suppose we mark a point on the circle, we can have only one tangent at that particular point. Another point on the circle, we can draw another tangent. So this is the concept. Okay. So this is the concept. So tangent means nothing but a straight line which intersects a circle exactly at 1 point. So now let us come to the first theorem in the chapter. Theorem 10.1. Tangent at any point of a circle is perpendicular to the radius through the point of contact. There are two things that we need to discuss here. What do you mean by the point of contact? So this is what we mean by the point of contact. The point at which the circle touches the tangent, that is known as point of contact. Point of contact. And the circle has center, it has radius, these are all radii, this is also radius. Okay, point to that. So now first the theorem says the tangent to any point of a circle is perpendicular to the radius through the point of contact. So let us draw a circle. Let us draw a circle. So there is a circle given. We'll draw it over here. So let us consider a circle with center C or O. We can have O is the center O, and there is a tangent. There's a tangent XY drawn to the circle at the point P. So what is given here? Given a circle, or you can say XY is a tangent to a circle with center O at the point. Tangent at the point. Where is the tangent? Tangent at the point P. Now, what do you have to show that? What does the proof says, or the theorem says? Is the tangent at any point on the circle. This is the point. Tangent at this point on the circle is perpendicular to the radius through the point of contact. We can draw different radius, but we can draw different radiuses. These are all radiuses, but it's perpendicular to the radius drawn. Which radius? Drawn through the point of contact. If you draw a point of contact, that is, this angle is 90 degree. So to prove, what do you have to prove? That is, to prove angle OPY or OPX is equal to 90 degree. That is, OP is perpendicular to XY. This is what we have to prove. Before coming to this, we just need to examine something. Suppose there is a point and a straight line. What is the distance between the point? If I join this point to the circle, the straight line, these are all distances. Distance between a point and the line, various points on the line. But among them, there is the shortest one. The shortest one is what? The perpendicular distance. The shortest distance between a point, and a straight line is the perpendicular distance. Okay, let us come, we'll prove. Let us go for the proof. Let us take, let Q be any point on the tangent other than P. So we are marking one point, which is that point, another point Q. Q is the point other than P. Where shall I mark other than P on the tangent? Somewhere, either here. I can mark somewhere here. Q is a point other than P on the tangent. Join OQ. We'll be joining OQ. We'll join OQ. Okay, so now when you look at this, we know that Q is a point outside the circle. Outside the circle. Why? It's evident from the figure. Q is a point outside the figure, right? And whereas P is on the sun, whereas P is on the circle, therefore OQ is greater than OP for any point, not only one point. Wherever I mark Q, it is outside the circle, because circle touches this is the tangent. Tangent means it touches exactly at one point. That means this P is the point on the circle. Wherever I draw, it is not, Q is not on the circle, because this being a tangent, it touches the circle exactly at one point. Okay, so that means Q is somewhere other than P. We have taken a point other than P. That means Q is outside the circle. OQ is greater than OP for any point on the circle. For any point on the circle. That means, in short, what then, OP is less than OQ for any point Q on the, not on the Q, for any point for any point P on for any point Q on the tangent. So OP is shorter than OQ for any point Q on the tangent. That means, what do we conclude? That means we conclude that OP is the shortest distance between O and the line, which is tangent. The line means the tangent. O and the tangent. O and the line. Therefore, OP is perpendicular to XY. OP is perpendicular to, because it is the shortest distance. Therefore, it is the shortest distance. That means, therefore, OP is perpendicular to OQ. Is it clear? That means we have taken one point Q other than P on the tangent. Wherever I take Q, it shows that this is greater than, or OP is shorter than. That means OP is the shortest distance between O and P. That means it is perpendicular. Okay, clear? Now we will go for one more point, one more theorem. Second theorem. The theorem part will be over. It's a simple thing. Okay, the length of the tangents from an external point to a circle are equal. Before coming to this, let us examine what this is, that external point. So let us consider a circle. There is a circle given. Let us consider an external point. I consider an external point O. I'm going to draw various lines to this, from this. When you draw this, you can see that out of them, two lines are special. What is the speciality of these two lines? What is the speciality of these two lines? One is this line, and the other one is the second line. That means there are two tangents. That means two tangents can be drawn. Two tangents can be drawn from an external point to a circle. So that means there is a circle given and there is an external point given. Then there are two tangents that we can draw from an external point. We cannot draw more than two. We can draw only two tangents from an external point to a circle. So this is the concept. The length of the tangents drawn from an external point to a circle are equal. That means there is a circle given and there is an external point. Then that means you can draw two tangents from the external point. So, and those two tangents are equal in length. This is what is said. We will remove this part and we will draw it again, as part of the proof of the theorem. Okay, fine, leave it. It's not easy to clear. The length of the tangents drawn from an external point to a circle are equal. The length of the tangents. How many tangents can be drawn? We have seen that 2 tangents can be drawn. These 2 tangents are of equal length. This is what we have to prove. Okay. So let us consider a circle. We'll consider a circle. Okay. And let us take a point. Let us take a point O. Let us take a point O or P. P is a point. Circle with center O. How many tangents can be drawn? We can draw 2 tangents. 2 tangents can be drawn to a circle from this external point. Okay. Let us name it as PT and PQ. So PT and PQ are 2 tangents to a circle with center O. PT and PQ are tangents from where? From P to a circle with center O. To prove, what is to be proved? To prove that, we have to prove that PT is equal to PQ. They are of equal length. This is what we have to prove. PT is equal to PQ. PT and PQ are of equal length. So construction. Let us join these two. Construction part. Join OT and OQ. Join OT and OQ. Also join OP. So now proof part. We know that this angle is equal to 90 degree. Why these 2 angles? Because those are the radiuses drawn to a radii of this angle, that is 10.1 or 10.1. The tangent at any point on the circle is any point on the circle. The point on the circle is are T and Q. Tangents at that point they are perpendicular. So what is given? We know that angle PTO is equal to angle PQO equal to 90 degree. Why? Theorem 10.1. Tangents are perpendicular to tangents. Reason, right? The reason, or right? 10.1. Tangents are perpendicular to the radius at the point of contact. Point of contact. Right? That's over. So now let us consider 2 triangles. In right triangles PTO and triangle PTO and PQ are they right angle triangles. Okay, we know that OP is equal to OP. Hypotenuses are equal, common, right? Because they are a hypotenuse of this 2 triangles, because hypotenuse means lying opposite to the right angle. Also OT is equal to OQ. Why? OT is equal to OQ. They are radii of same circle. That means therefore triangle, look at the figure and we'll write. Therefore triangle PTO is congruent to triangle PQO. What kind of congruence? It is RHS congruence. So that means PT is equal to PQ. CPCT. Corresponding parts of congruent triangles. So PT is equal to PQ. That is what we have to prove. We proved it. Now along with that, we can prove few more things from this. Those are I'll put it over here in extra. Okay, those we can prove. I can prove that these 2 triangles are congruent. Therefore there are more CPCTs coming. What are the CPCTs coming? We can say that these 2 angles are equal. Why? That is CPCT again, these two triangles are congruent, we can say additional. Angle TPO is equal to angle QPO. The name and nomenclature doesn't matter, the concept, that is PO bisects, this is the concept that you have to learn, bisects angle TPQ, angle TPQ, bisects angle TPQ. Also we can say that these two angles are also equal, these two angles are also equal, am I right? CPCT angle PO bisect what? Angle TOQ. So these are the additional things that we have learning from this theorem. This is the rider or the remaining additional point that we learned. That means this line, the line joining the point from where the tangents are drawn to the circle bisects the angle between the tangents, this one as well as this one. Okay, similarly these two are equal, these two angles are equal, these two angles are equal because CPCT. So we have discussed two things. One is, first concept is, what was the first concept or the first theorem? That is tangent is perpendicular to the radius at the point of contact. Second concept that we have learned is, that is, if there is a circle given and there are two tangents drawn from an external point, P and T, P and S, then these are two tangents, then PT is equal to PS. Also, in addition to this, we have also learned that this line bisect the angle between the tangents. Similarly, this line bisects this angle also, the entire angle also, this is bisected. That means these two are equal. Is the concept clear? So with this, we will be going for the questions of the reader. So now let us examine few questions from the reader. Let's go for exercise 10.1. So first question is, fill in the blanks and simple type of question. How many tangents can a circle have? We can draw enormous number of tangents to a circle. At this point, another point, I have another tangent here, another tangent here, another tangent here, enormous number. So for each point on the circle, we can have one tangent. That means a tangent circle can have infinite number of tangents. A tangent to a circle intersects it at dash points. You know that a tangent intersects the circle exactly at one point. The line intersecting a circle in 2 points is called secant. A circle can have dash parallel tangents at most. Dash parallel tangents. So the concept of parallel tangents. So it's a very simple thing. Let us draw a circle here and we draw parallel lines, parallel straight lines. Let us draw some parallel lines. When you draw parallel lines, you can see that all of them are secant, and now here we come one tangent and the other tangent. So these two lines are parallel. A circle can have dash parallel tangents at the most. One set at a time. You can draw another parallel set of tangents. You can draw another third set of parallel. So you can draw a fourth set of parallel. So enormous number of tangents. This particular question can be interpreted in two ways. So the a circle can have dash parallel tangents at the most, one set at a time. Similarly, you can draw enormous number of sets of or pairs of parallel tangents. And the common point of a tangent to a circle and the circle is called. That means the point common to circle and a tangent. The point common to circle and a tangent. The point common to circle, and this is known as what we call point of contact. Point of contact. So those are just silly fill in the blanks. Let us come to the first question. That is 10.13. A tangent PQ at a point P on circles of radius, a circle of radius 5 means the line through the center. Make the lines through the center at O. Line through the center O at a point Q. So that OK is to find the length of. So there is a tangent. Let us examine that question. A tangent PQ at a point P of a circle. Tangent PQ. So there is a tangent PQ. there is a tangent PQ. We will change this point. So there is a tangent PQ. PQ. At a point P on the circle of radius 5. Radius is 5 centimeter. O meets a line through the center O at a point Q, so that OQ is, say, a line is drawn through the center. Line is drawn through the center. A line is drawn through the center, which means so that OQ is equal to 12 length of PQ is asked. So we know that this angle is 90 degree, angle OPQ is equal to 90 degree, and this is the hypotenuse, and you have to find the length PQ. A tangent PQ at the point P of a circle of radius 5 cm meets a line through the center O at the point Q. So that OQ is 12 cm, length of PQ is asked. Use Pythagoras theorem and find it's not 13 because this is the hypotenuse. PQ is equal to root of OQ square minus OP square. You can find that out. Now, question exercise 10.2. Exercise 10.2. We have to do certain, solve out examples as well. We will come to that one by one. Before that, let us go to these questions. Exercise 10.2. Exercise 10.2. From a point Q, the length of the tangent to a circle is 24 cm, and the distance of the point Q is 25 cm, the radius of the circle. So there's a circle given. You can just draw a small figure there. There's a circle. From a point Q, the length of the tangent to a circle, from a point Q, the length of the tangent to a circle is 24 centimeters. So let PQ be the tangent, and the distance Q from the center is 25. So let us consider a circle with center O, and this distance is 25 centimeters. Find the radius of the circle. Let this be the radius. That is, this is what we have to find. OP or POP. We know that angle OPQ is equal to 90 degree. Reason, either theorem 10.1, or you can say that tangent is perpendicular. Tangent is perpendicular to the radius at the point of contact. So now in this triangle, you can use Pythagoras theorem. OP is equal to root of, or you can write the Pythagoras theorem. OQ square is equal to OP square plus PQ square, or OP square is equal to OQ square minus PQ square, or that is equal to 25 centimeters square minus 24 square, that is 625 minus 576, that is equal to 49. Therefore, OP is equal to root of 49, and that is equal to 7 centimeters. Option A. Question number 2. Again, figure is given. The figure is given. Figure is given. This is the figure given. Let us take that figure. Let us take the figure. The figure is given. In the figure, angle PQ and PT and PQ are the tangents to a circle. This angle is when we find the angle, this angle is 110 degree. POQ is 110 degree, and PTQ is equal to, find the, we have to find the value of this angle. This is what we have to find out. Okay, in this figure we can see that this angle is equal to what? 90 degree. Reason, tangent is perpendicular to radius at the point of contact. So we have a quadrilateral in which, three of that is 1, 2, 3, 4. It's a quadrilateral. In quadrilateral POQT, angle P plus angle O plus angle Q plus angle T is equal to 360 degrees. So here it is equal to 90 plus 110 plus 90 plus angle T is equal to 360 degree. So here this is 290 plus angle T is equal to 360 degree, or angle T. Angle T means angle PTQ is equal to 360 minus 290 degree, and that is equal to 70 degrees. Okay, so the next question number 3. Let us consider, if tangents PA and PB from a point P to a circle O are inclined to each other at an angle of 80 degree PAO. Same questions. You can, I'll just draw the figure and explain it. You can do it on your own. Okay. Tangents PA and PB. P is common, so that means P is outside. Tangents PA and PB to a circle with center O are inclined to each other at an angle of 80 degree. Find the measure of angle POA. So this is 80 degree. The entire angle is 80 degree. Angle, so that it is inclined to each other, so that the tangents PA and PB from the point P to a circle with center O are inclined to each other at an angle 80 degree. So they are inclined at 80 degree. Angle POAO asked. So what we do is that in this we join OA, we join OA and OB. We join OA and OB. OA and OB are joined. So, and also PO is joined. So now join OA, OB and OP. In the theorem 10.1 we have seen that, sorry 10.2, so you see that PO bisects angle APB. Reason, theorem 10.2. It's the fallout of that. So this angle is actually equal to 40 degree and this angle is also equal to 40 degree. Therefore, angle APO is equal to 40 degree and this is equal to 90 degree. Further, angle PAO is equal to 90 degree. Reason, theorem 10.1, that is tangent is perpendicular to the radius. Tangent is perpendicular to the radius, that is the reason. Now when you take a triangle and use angle sum property, in triangle PAO, angle P plus angle A plus angle O equal to 180 degree. Out of that we have, this is angle P. Angle P means this angle, smaller angle, that is 40 degree plus angle A, that is 90 degree, plus angle O is equal to 180 degree and POA. So this is 130 plus angle O is equal to 180 degree. Angle O is equal to 130 minus 180 minus 130, that is equal to 50 degree. 50 degree. So angle POA is equal to, actually it is equal to 50 degree. 50 degree. So let us come to the next question. Question number 4. Prove that tangents drawn at the ends of the diameter of circle are parallel. Show that or prove that tangents drawn at the end points of the diameter are parallel. So there is a circle and there is a diameter. A, B is a diameter of a circle with center at O. We have to prove that the tangents drawn at the ends of the diameter. So it's a tangent drawn. There's a tangent drawn. It's a tangent drawn. We can call it as X. Y is a tangent drawn. And PQ, another tangent drawn. PQ at the end points. To prove that what? These two are parallel. This line and this one are parallel to each other. Prove that the tangents drawn at the end point of the diameter are parallel. So for that, what we take? Given part. Given part what? XY and PQ are tangents at A and B, where AB is the diameter of the circle at or circle with center O. This is what we have to, is given. What is to prove? To prove that, to show or to prove that XY is parallel to PQ. This is what we have to prove. So in this we know that this angle is equal to 90 degree. How? This angle is equal to 90 degree. This angle is also equal to 90 degree. From this figure, angle OBQ is equal to 90 degree. Reason? Tangent is perpendicular. Tangent is perpendicular to the radius. Okay, similarly, what about this angle? Angle XAO is equal to 90 degree. Reason is same. Therefore, that means angle OBQ is equal to angle XAO. XAO. This alternate interior angles are equal. This implies that XY is parallel to PQ. Alternate interior angles are equal. Therefore, this line is parallel to PQ. So next question. Prove that the perpendicular, question number 5. Prove that the perpendicular at the point of contact to a circle passes through the center. Prove that the perpendicular at the point of contact of this circle of the tangent passes through the tangent passes through the center. Don't make it sharp. Okay. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Passes through the center. Make it a bit short. Okay. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So we have a, this is actually the reverse of converse of 10.1. There's a circle. There's a circle. Okay. Prove that the perpendicular at the point of contact to the tangent. So there's a tangent. There's a circle. So let us consider a tangent to a circle. Let us consider a tangent to a circle. It's not okay. Let us consider a tangent. The tangent is PQ or AB is the tangent to a circle at the point P. The point of contact is P. So that the perpendicular at the point of contact to the tangent to the circle passes through the center. So let O be the center of the circle. So this is the given. So what is given is AP or AB, anything. AB is a tangent. You can forget that point B. AB is the tangent to the circle with center O at the point P. Center O at the point P. Prove that the perpendicular at the point of contact. So we have to show that the perpendicular passes through the center. Okay, we'll join this. I don't know whether it's perpendicular. Obviously, it has to be perpendicular, right? So we have to show that the perpendicular passes. Let OP is not perpendicular to AB or to the tangent. Let it not be. We are going by converse. Okay, let it not be perpendicular. Not perpendicular to AB. This is not 90 degree. This is not 90 degree. No, this is not 90 degree. Let consider a point. Let O dash. The O dash is a point. O dash P be perpendicular to AB, where O dash is a point inside the circle other than O. So we will join that. So that means we got, this implies angle O dash PB is equal to 90 degree. But we know that, but OP is the radius to a circle, is radius. Therefore, OP is perpendicular to AB. This implies that angle OPB is equal to 90 degree. OPB is 90 degree. O dash PB is 90 degree and OPB is 90 degree. This implies a concrete situation that angle OPB is same as angle O dash PB, both of them 90 degree. This is possible. This is possible. This is possible. This is possible only if O coincide with what? Or O dash coincide with O. Therefore, that means this is possible only if these 2 points coincide. This implies that the perpendicular, therefore the perpendicular at P passes through something happened. Okay, passes through the center. Oh, that means actually OP dash, we can put one more sentence in between. Actually, this coincide means O dash P and OP are same. That means whenever I draw a perpendicular, we have drawn this as perpendicular. When I draw this perpendicular, it is obviously passes. So these two are one and same. O dash coincide with O. So that means whenever we draw a perpendicular, that has to pass through the center. So I'll repeat it. That is, we have taken that P is not, let OP is not perpendicular, and there is another point, O dash P. You can take O dash or A, B, C, D, something other than what is given here. O dash P is perpendicular to AB. If O dash P is perpendicular to AB, then we have also OP is the radius. That means OPB is also perpendicular. That means angle OPB is same as O dash radius. This can happen only if O coincides with O dash. That means OP and O dash P are one and the same line. That means the perpendicular pass through the center. Next question. Find the length of the tangent at the point A at a distance 5 cm. Center of the circle is 4. Find the radius of the circle. This you can do on your own. Next question. Two concentric circles of radius 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. So we will draw there are two concentric circles. There are two concentric circles. Let us see. We will put up this after that. There are two concentric circles. Two concentric circles of radius 5 cm and 3 cm. Two of them are there. Two concentric circles of radius 5 cm, and one is this one circle, and there is one more circle. Two concentric circles are there. There are two concentric circles. Okay, and radius is 5 cm. There are two concentric circles. We are answering question number 7. There are two concentric circles. Question number 7. Question number 7. Two concentric circles of radii. So the first one, the radius is 3 centimeters. And the second one, the radius is OA and OB beta radii are 5 centimeters. First one is 3 centimeters, and the next one is 5 centimeters. Find the length of the chord of the circle that touches the smaller. This is a chord. So let. Okay, we'll change the. Okay, let. Okay, let CB or BC be the chord of the circle, larger circle. It's a chord for the larger circle. Find the length of the chord of the larger circle touches the smaller circle. So you have to find the length of the larger circle which touches the smaller circle. So this is the situation. I will do one thing. I will put up a little more larger figure. That will be convenient. I'll put up a larger figure. Okay. So there are concentric circles, and O is the center. The radius are, so we have been asked to find the tangent, the length of the chord of the larger circle. Let A, B be the chord. We change the naming, and so we can draw. Let this be D. This distance is the radius of, actually the radius of the larger circle, which is 5 centimeter. And this one is the radius of the smallest circle. This is the radius of the smallest circle. That is 3 centimeter. Find the length of the larger circle. And radius is also given. Radius of the circle is given. No. Two concentric circles of radii. Okay. The length of the chord touches the large circle. larger circle touches, the smaller circle is asked. So this is 3 centimeter. What about this distance? That distance is also equal to 3 centimeter. Why? Because OD is the radius. So let AB be the chord of larger circle that touches the smaller one. To find AB. So now OD is perpendicular to AB. Reason why? AB is chord of the larger circle, but as far as the smaller circle is concerned, it goes like this. That means tangent. This is a tangent. Tangent is perpendicular to radius. Therefore, in triangle ODB, it's a right angle triangle. DB is equal to root of Pythagoras theorem. Using Pythagoras theorem, it will be equal to OB square minus OD square. That is equal to root of 5 square minus 3 square. That is equal to, calculate it's 4 centimeters. So this is 4 centimeter. AB is a chord. It's tangent of the smaller circle, but it's the chord of the larger circle. Therefore, perpendicular from center to chord bisect the chord. DB is equal to 2 times AB. Sorry, AB is equal to 2 times DB. That is equal to 2 into 4. That is equal to 8 centimeter. Why this is 2 times? Because this is a tangent to a smaller circle, as is shown here. At the same time, it is a chord to the larger circle. When you look at it as a chord, when you're looking at it as a chord, this is the perpendicular from center to the chord. Therefore, it bisects. Therefore, DB is half, or D is the midpoint. That means AB is 2 times this portion for 8 centimeters. Question number 8. Question number 8. Quadrilateral ABCD is drawn to circumscribe this circle. Prove that AB plus CD is equal to AD plus BC. So let us copy the question, the figure. So it's easy. To put it over here. Question number 8. We're talking about question number 8. We have to prove that AB plus CD is equal to AD plus BC. Question number 8. Question number 8. Question number 8. So we have to prove that. That is a quadrilateral is drawn to circumscribe a circle. Right? ABCD. To prove that, we have to prove that AB plus DC is equal to AD plus BC. Let us take it once again. AD plus BC. Okay. So that this opposites, when you add the sum of the opposite sides, when you add the measurement of these two sides, that is equal to the sum of the other sides. Okay. Now, when you look at this point, I will just change the color. When you look at this point, these two are actually what? Tangents. These two are actually tangents. When you look at D as an external point. So, we can say that, I'll start from here, this point P. AB or AP is a tangent. AS is also a tangent. I can see that from the figure, AP is, when I am writing, I am very careful. This is the trick. We want AB plus DC on one side and AD plus BC on the other side. Often students are seen to make mistake and just they may get messed up. It's very simple. So what are the components of AB here? Components pieces or alphabets coming AB, PB. DRRC. I ensure that those come on one side. Agreed? That's it. I am going to write in such a way that AP, PD, DR and RC come on one side. And what comes on the other side? AS, SD, because it's a component of other side. So ASAP is equal to AS 1. Similarly, BP is equal to BQ, relation number 2. And the third thing, DR is equal to DS. I am very particular when I am writing it. That is components of this AB, which are the part of AB, parts of AB, AP and PB on one side. On the same side, I get parts of DC, that is DR. Now RC should come. RC is equal to CQ. What is the reason for all the four? Nothing but tangents drawn from where? Drawn from an external point to a circle are equal. Now adding 1 plus 2 plus 3 plus 4. Adding 1, 2, 3 and 4. What happens? We have AP plus BP plus DR plus RC is equal to AS plus BQ plus DS plus CQ. That means AP plus, and next step I am going to combine AP plus BP and DR plus RC. What is AP plus PB? That is AB plus DR plus RC, that is DC. Now I am going to rewrite this. AS and BQ is coming here. I am going to rearrange it. Okay, ready? AS plus DS, rearrangement, plus what is the rearrangement? BQ plus CQ, rearranging. This is equal to AS plus DS. Let us see. AS plus DS. AS and DS. That is AD plus BC. Hence, true. So the trick is writing all these things on one side. Next one. Question number 9. In figure 10.13, xy and x dash y dash. X, y and x dash y dash are two parallel tangents to a circle with center O. Another tangent AB with point C as contact intersect xy and x dash y dash at the point B. xy at A and x dash y dash at B. Prove that AOB is 90 degree. So let us copy this figure so I can save time drawing it. Let us read the question again and examine the figure. In the figure, it is given that in the figure it is given x, y and x dash y dash are two parallel tangents to a circle with center O, and another tangent AB is another tangent with point of contact C intersecting xy at A and x dash y dash at B. Prove that this angle is equal to 90 degree. This angle is to be proved as 90 degree. So this is the situation. Okay, this is the situation. So let us consider fresh and a little larger figure. So we have to solve question number 9. We are solving question number 9. Question number 9. This is what we have solved in question number 9. So in this, these are all tangents. XY is tangent, X dash Y dash is tangent, AB is also tangent, point of contact. Now we have to prove that, to show that angle AOB is equal to 90 degree. This is to be proved as 90 degree. That is our task. This is 90 degree. This is what we have to prove. Okay, so let us make some small construction. The construction is, let us join. Oh, it's not clear here. Let us join OC. OC is joined. OC is joined. Okay. Now, when you compare this triangle, on first thing, in triangle AOC and triangle AOP, AP is equal to AC. Why? AP is equal to AP because those are two tangents. These are two tangents drawn from the external point A. Tangents drawn from which point? External point. External point. Similarly, OP is equal to OC. Why? OP and OC, they are radii of same circle. Then one more. OY is equal to OY, common. So there are two triangles in which all the three sides are corresponding sides are equal. Therefore, implies what? Triangle AOC is congruent to triangle AOP. That means I can name that angle AOP or AOC is equal to angle AOP, CPCT. I'll call it as this angle can be called as, this is called as AOP is 1 and 2. That is, angle 1 is equal to angle 2. Similarly, we can establish a congruence between these two triangles. Which are the triangles? In triangle QOB and triangle QOB and triangle COB, we know that QB is equal to BC. QB is equal to BC, tangents. And OQ is equal to OC. OQ is equal to OC, that's radii. This is tangents drawn from external points. Same comes over here. And OB is equal to OB, common. You can show that, same way you can show that what these two triangles are. Triangle QOB is congruent to triangle COB. QOB is congruent to triangle COB. That means these two angles are also equal. Which two angles are equal? Angle 3 is equal to angle 4 corresponding CPCT. Angle QOB is equal to angle QOB is equal to angle COB. That is, angle 4 is equal to angle 3. They are equal. But what do you know about angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to what? 180 degree, because PQ is a straight line. PQ is, a straight line. Straight line because it's a parallel line. PQ is a straight line. But what do you know about 2? 2 is same as 1. 1 plus angle 1 plus 3 same as 4, or 4 is same as 3. So here the correction is 2, not correction, substitution is 2 is same as 1. We have proved that. And 3 same as 4, that's also we proved. So instead of 4 we write that is equal to 180 degree. This means that 2 times angle 1 plus 2 times angle 3 is equal to 180. Or angle 1 plus angle 3 is equal to 2 is common. or angle 1 plus angle 3 is equal to 180 by 2, that is equal to 90 degree. What is 1 plus 3? 1 plus 3 is nothing but AOB. That is angle AOB is equal to 90 degree. That is what is you have been asked to prove. AOB, to show that angle AOB is 90 degree. This is what is asked. Okay. Next question. Next question. Question number 10. Question number 10. I'll take it and put it over here. Question number 10. Question number 10. Question number 10. Prove that the angle between, question number 10. Prove that the angle between two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segments joining the points of contact at the center. So, prove the angle between the two tangents drawn from an external point to a circle. Supplementary to supplementary angles. Two angles are said to be supplementary. Supplementary if sum is equal to sum of the angles is equal to 180 degree. Angle A and angle B are called supplementary angle if angle A plus angle B is equal to 180 degree. We prove that the angle between two tangents drawn from an external point to a circle. So let us consider a circle. Okay, let's consider a circle. And there is a point, circle with center O. And there is a point P. And there are two tangents drawn, PT and PS. Or PT and PS are two tangents drawn from an external point to a circle. Is supplementary to the angle subtended by the line joining the point of contact at the center. Which are the point of contact? The point of contacts are this. So I'll join that with the center. So now something is supplementary. What are supplementary? Something is supplementary. That is, you have to show that. Prove that the angles between the two tangents. This is this angle. From an external point of a circle. Okay, I'll close that. Angle between two tangents drawn from okay, that's about that point, drawn from an external point to a circle. Okay, I'll close this part. Let us read without okay. Is supplementary to the angle subtended by the lines. So what is it? Prove that the angle between the two tangents is supplementary to the angle subtended by the lines joining the point of contact at the center. So this is supplementary to this angle. The angle is supplementary to the angle subtended. I repeat, prove that the angle between the two tangents is supplementary to the angle subtended by the line segment joining the point of contact at the center. Okay, so these two are, that is, the supplementary means, that is P and O are supplementary. That means to prove that angle P plus angle O is equal to 180 degrees. It's a very simple question. We know that PT and PS are tangents. That means, therefore, we can say that this angle is 90 degree. Why? These two are angle PTO is equal to angle PSO is equal to 90 degrees, and tangents. Tangents are perpendicular to radii or radius. That is the point of contact. Now, when you look at this quadrilateral, is over. Next step is over. In quadrilateral, PTOS. First I'll write angle, one letter, try to avoid this way of writing. If you can, you write 3 letters. If those who, it's not possible for those, I'm writing this for those people who can't follow it. Okay, if you write 3 letter angles, it may be a little confusing. Angle P plus angle T plus angle O plus angle S is equal to 360 degree. Here angle T, angle P means this angle. Angle T means this angle, actually PTO. Angle P plus T means angle PTO. Plus angle O plus angle S means angle PSO is equal to 360 degree. That means angle P plus this is 90 given plus angle O plus this is 90 given is equal to 360. So that means angle P plus angle O plus 90 and 90 plus 180 is equal to 360. Therefore, angle P plus angle O is equal to 360 minus 180, that is equal to 180 degree. Sum of two angles is 90 degree, I mean 180. Therefore, angle P and angle Q are supplementary. So that means when you add these two angles, we get their sum is what? 360. 180 degree. Therefore, they are supplementary. Next one is question number 11. So, prove that the parallelogram circumscribing a circle is a rhombus. Prove that the parallelogram circumscribing a circle is a rhombus. What does that mean? Parallelogram circumscribing a circle. So, there is a parallelogram which circumscribes. So, let us consider a parallelogram. Which circumscribes a circle, that means the circle is inside. Let us try to put up a circle there. Okay, so there is a circle, is a parallelogram. Let us name it as A, B, C, D. It circumscribes a circle with center O, and the circle touches at the points P, Q, R, and S. Expected to touch over. Touches. So we'll bring it down. Touches there. Okay. So now we have to prove that this is a rhombus. A parallelogram is a rhombus. Parallelogram ABCD. Parallelogram ABCD becomes a rhombus. When at any adjacent sides are equal. That means AB is equal to BC, or we can prove that CD is equal to BC. Any adjacent sides, if we can prove that any adjacent sides are equal, that means parallelogram opposite sides are already equal. If adjacent sides are equal, these two are already equal. If this is equal, these two are equal, that means this is equal to this, equal to this, equal to this, all sides are equal, it become a rhombus. So a rhombus is a parallelogram in which adjacent sides are equal. So given, what is given? Given that parallelogram ABCD circumscribes a circle with center O and which touches at the point PQRs. Now, to prove that ABCD is a rhombus. Now, when you look at the figure, it is seen that I am not explaining why, what is the reason. I say that AP is equal to AS. AP is equal to AS. Similarly, BP is equal to BQ. BP is equal to BQ. SDSR or DR is equal to DS. DR is equal to DS. And RC is equal to CQ. What is the reason for this? When you look at this, these are the tangents. So tangents drawn from external common reason or common theoretical reason. Tangents drawn from an external point to a circle are equal. So if you want, you can name it as 1, 2, 3, 4 and adding 1, 2, 3 and 4. When you add all these things, 1 plus 2 plus 3 plus 4, what happens? That is AP plus BP plus DR plus RC is equal to AS plus BQ plus ST plus CQ. When you look at that, AP plus BP, AP plus BP, AP plus BP, that means that's same as AB. So AB plus DR plus RC, DR plus RC, that is DC, is equal to AS plus SD, rearranging AS plus SD plus BQ plus CQ, that is equal to AD plus BC, AD plus BC, AD, but AB and DC, what do you know about is given that ABCD is a parallelogram. AB and DC are AB is equal to DC, opposite sides are equal, that means 2 times AB is equal to AD plus BC. What about AD and BC? Both of them are equal. So you can say that 2 times BC, cancelling 2 and 2, implies that AB is equal to BC. That in the parallelogram ABCD, AB is equal to BC, adjacent sides are equal. This implies that ABCD is a rhombus. ABCD is a rhombus. Now we move on to next question. That is question number 12. It's a large question. It's a bit long. A triangle ABC is drawn to circumscribe a circle. I just put it over here. Okay. Question number 12. A triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segment BD, this is a triangle ABC, such that the segment BC is divided by the points D, segments into which BC is divided by D are 8 cm and 6 cm. That means there are 2 portions which D divides. BC is divided into 2 portions, one is 8 cm and the other one 6 cm. Find the measure of side AB and AC. The remaining is not okay. Required. That's the portion of the next question. Question number 12. So there's a triangle is drawn to circumscribe a circle. This is 8. This is radius is 4 cm and it's divided by D divides BC into 2 parts. One is 8 cm, 6 cm. Find the measurement of side AB. This is what is asked. AB and AC. So in order to do the question, I will just take what is required, the figure. I'll copy the figure once again and then we will use the figure alone here. Okay. We'll put it over here. Okay, this requires a bit of calculation. So over here we need to write a lot of things in this question. Okay. So actually this is not from the board perspective. I don't expect this question to be asked for board exam because it's a lengthy question. So now let us mark these 2 points. We can name this. This as this can be rewritten as D. This is E. Okay, this is E, and this can be rewritten as F. F. So we can say that this is from the figure BF is equal to BD, and similarly CE is equal to CT. What is the reason? Tangents drawn. Tangents from external point. Tangents from external point. So that is that means this is actually 8 centimeters. This is also 8 centimeters. So now this is missing. If I can find the measurement of this, will be equal to this. If I can find the measurement of AF, I'll get this as well as this. That means adding 8 to that, not 8, this is 6. This will be 6 centimeters. 6 centimeters. Adding 8 to this and 6 to that, you'll get the entire, the whole thing. So I can put up a fresh figure there. I'll remove this. Okay, a bit large. So we get a very clear picture. Okay. So now what the namings that we have given is, this is E and this was F. This is 8 centimeter, this is 6 centimeter. Let us take let AF is equal to AE is equal to X. So we have taken this as X. So in this particular question, and we can join these two. We'll join all of them. In this particular question, how we are going to find the value of X is a really strange method. That we'll be finding the area of the triangle in 2 different ways, and then we will equate that. Sounds strange, right? We will find the area of the triangle in 2 different ways. One is our Heron's formula. What is the area of the triangle? Area of triangle ABC is equal to root of S into S minus A into S minus B into S minus C. What is S actually? Semi-perimeter, that is A plus B plus C by 2. What is A? On measurement of one side, that is, this will be equal to 14. 6 plus 8, 14, plus this is 8 and X. 8 plus X. This is 6 plus X whole divided by 2. When you add this, 14 plus 8, 22, 26, 28. 28 plus X plus X, that is 2X by 2. When you divide that, you will get 14 plus X. So this is equal to root of S is 14 plus X into S minus A. This is what we are going to write. That is S minus A. Okay. That is 14 plus X minus A, one side. What is the measurement of one side? That is 14 subtracted. Into, again, S is 14 plus X minus measurement of one side. I'll subtract this side. What happens when I subtract? Actually, I have to put 14 plus X. Within bracket, I have to inside the measurement. 8 plus X is, so we'll get 14 plus X minus 8 minus X. Opening the bracket. X and X cancel. 14 minus, that will do. That is 8 minus X. The next bracket, again 14 plus X, that is into C, S minus C. S minus C. What is C? This side, the third side. 6 minus. Remember this minus coming and opening the, I'm skipping one step. That is, next step will be 14 plus X minus of 6 plus X. What happens when you open the bracket? 14 plus X, 14 plus X minus 6 minus X. That is what is written here. That is equal to 14 plus X. Here 14 and 14 cancels. X will remain. Here X cancel. 14 minus 8 will be 6. Here X cancel. 14 minus 6 into equal to 8. That is equal to 6, 8, 48. Root of 48X into 14 plus X. This is the area of that triangle. But the area of this triangle can also be identified in a different way. The area of the triangle, I'm writing in another color. Area can also be considered as area of triangle ABC can be written as area of 3 smaller triangles. Sum of area of triangle OBC plus area of triangle AOB plus area of triangle AOC. So when you look at this is equal to half into base. What is the base of this triangle? That is 8 plus 8, that is 14, into height. What is the height? Height is, as far as the question is concerned, it's a radius 4 centimeters. That means this is actually 4 centimeters. Right? We can't see that. 4 centimeters. The height is actually, the radius is actually 4 centimeters. This is 4, this also 4, this also 4. All the radii are. So, 14 into 4 plus, here it is half into height, base is 8 plus x into 4 plus half into 6 plus x into 4. This will be 4 2's cancel, 7 4's 28 plus 2 goes there. It will be 16 plus 2x plus 2 goes 12 plus 2x. So that will be altogether equal to 2 plus 6, 8, 8, 60. So adding these numbers. Okay, so 28, 56 plus 4x. So 58 plus 4x is the area of the triangle when you take in different way. 56 plus 4x. Now we already have this in the area in different, another form, Heron's formula. We have root of 48x into 14 plus x. But we have got the area in another form. But what do you conclude from this? This is 1 and 2. From 1 and 2, we have that root of 48 root of 48x into 14 plus x is equal to 56 plus 4x. 56 plus 4x. In order to solve x, what you have to do is you have to square both sides. So you'll get 48x squaring both sides. 48x into 14 plus x is equal to 56 plus 4x. What I can do is that from this I'll rewrite, I'll take a 4 outside. 4 into 14 plus x. 4 into 14 plus x whole square. This is equal to 16 into 14 plus x whole square. Here it is 48x into 14 plus x. So we can go for some cancellation. 16 will go 3 times. 1 14 plus x and 1 14 plus x cancel. So what remains is 3x is equal to 14 plus x, or 3x minus x is equal to 14. 2x is equal to 14, x is equal to 7. So once you get the value of x we got it as x is obtained as 7. If this is 7, this is 8, you have been asked to find the measurement of two sides, AB and AC. AB and AC are asked. AB and AC. AB is actually x plus 8. X plus 8. That is 7 plus 8. That is equal to 15 centimeter. And AC is asked. That is actually x plus 6. That is 7 plus 6. That is equal to 13 centimeters. So this is how we do. Just pause the video and go through it once again. Basically, we use the area of the triangle in two different ways. First one is Heron's formula we use. Second one is we use the area of sum of two smaller triangles. We'll get, when you add the area of 3, മൂന്നെണ്ണത്തിന്റെ ചെറുതിന്റെ ഏരിയ ആഡ് ചെയ്യുമ്പോൾ വലിയ ട്രയാങ്കിളിന്റെ ആഡ് ചെയ്യും. ഇത് രണ്ടും ഇക്വേറ്റ് ചെയ്യുമ്പോൾ ഇത് സ്ക്വയർ ചെയ്യാൻ ശ്രദ്ധിക്കുക. കൂടുതലും ആൾക്കാർ എഴുതുന്നത് സാധാരണ വാട്ട് വി ഓഫൻ സീ ദ സ്റ്റുഡൻറ്റ് എക്സ്പാൻഡ് a plus b ഹോൾ സ്ക്വയർ. ഞാനത് ഉപയോഗിച്ചില്ല. ഇവിടെ 14 പ്ലസ് എക്സ് കൊണ്ട് ഡിവൈഡ് ചെയ്തു രണ്ട് സൈഡ്. അത് സാധിക്കുന്നത് എന്തുകൊണ്ട് വെച്ചാൽ 14 പ്ലസ് എക്സ് ഇസ് നോട്ട് ഈക്വൽ ടു 0. ഓക്കെ, കാരണം എന്താ 14 പ്ലസ് എക്സ് അല്ലെങ്കിൽ എക്സ് കനോട്ട് ബി ഈക്വൽ ടു -14. അത് തിയറട്ടിക്കൽ കോൺസെപ്റ്റ് ആണ്. അതുകൊണ്ട് അതിനെപ്പറ്റി അത്ര ചിന്തിക്കേണ്ട. ചിലവർക്ക് അത് മനസ്സിലാവും, എല്ലാവർക്കും അത് മനസ്സിലായിക്കൊള്ളുന്നില്ല. So I'm going to leave that part. I'm cancelling 14 plus x on both sides. The reason for cancelling 14 plus x is 14 plus x is not equal to 0. Equal to 0 ആയി കഴിഞ്ഞാൽ x നെഗറ്റീവ് ആവും. എക്സ് ഒരു ട്രയാങ്കിളുടെ സൈഡാണ്, ഒരു സൈഡിൻ്റെ ഒരു പകുതി ഒരു ഭാഗമാണ്. അതുകൊണ്ട് നെഗറ്റീവ് ആവില്ല എന്തായാലും. So I'm cancelling both sides. So 3x minus x is equal to 14. 4x is equal to 7. So that means sides are ഇനി അതല്ലാതെ ആരെങ്കിലും എക്സ്പാൻഡ് ചെയ്തിട്ടുണ്ടെങ്കിൽ അവസാനം അവർക്ക് കിട്ടുക എക്സ് മൈനസ് 7 അങ്ങനത്തെ ഒരു ഇക്വേഷൻ ആയിരിക്കണം ഇൻറ്റു എക്സ് പ്ലസ് 14. അത്തരത്തിലുള്ള എന്തെങ്കിലും 3 or 4 ചിലപ്പോൾ പുറത്തുണ്ടാവും, ഉണ്ടായിക്കോളം നിർബന്ധമില്ല. equal to 0. ചിലപ്പോൾ 4, 5, 6 എന്നേ പുറത്തുണ്ടായിക്കൊള്ളണം. That means x cannot be equal to minus 14. ഇവിടെ x ആകെ possibility 7. അതാണ് നമ്മൾ ഇവിടെ നിന്ന് തന്നെ ചെയ്തിട്ട് എളുപ്പത്തിൽ ഇതിങ്ങനെ ചെയ്യാവുന്നതേ ഉള്ളൂ. Next question. Question number 13. Prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. എന്തായി പറഞ്ഞിട്ടുള്ളത്? Question number 13. Question number 13. We'll put it as 13. Question number 13. Prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. Supplementary angles at the center. Prove that the opposite sides of a quadrilateral circumscribing. So there's a quadrilateral. I'm just taking it as a parallelogram. What is available is it's also a quadrilateral. Okay. Parallelogram circumscribing okay. So a quadrilateral, prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. So circumscribing a circle. So I'll put a circle also inside. So that's it. Okay. So here's quadrilateral. ABCD is a quadrilateral. A, B, C, D is a quadrilateral circumscribing a circle with center O. And let the circle intersect touches the quadrilateral at P, Q, R, and S. We have to show that subtend supplement opposite sides. What are the angles subtending opposite angles? Circles subtend or supplementary angles. At the center of the circle, opposite sides subtend supplementary angles. That means the angles. Let me first draw the angle subtended by the sides at the center. One angle is this AOP. Other angle is DOC. These are the two angles. So we have to prove that this one plus these two angles are supplementary. I repeat, prove that opposite sides of the quadrilateral, opposite sides are AB and DC, subtend supplementary angles at the center. This is supplementary as well as this is supplementary. So we have to prove that this angle plus this angle is equal to 180 degree. So for that, what I'm going to do is that I'm just write down ABCD is a given quadrilateral with so and so over the circle. And now we have to join and make a construction. What is to be proved? To prove that angle AOB plus angle DOC equal to 180. That is, the angles are supplementary. Sum is 180. Similarly, AOD plus angle BOC is equal to 180 degrees. This is what we have to prove. We have a construction part. Very simple. Join OP, OQ, OR and OS. Right. Now, coming to proof. You take triangle AOP and triangle AOS. AOP and AOS. AP is equal to AS. AP is equal to AS. AP equal to AS. The reason tangents drawn from external point. I'm not writing that completely. Tangents drawn from external. Similarly, OP is equal to OS, the radius of the circle. OA equal to OA, common. That means triangle AOP is congruent to triangle AOP is congruent to triangle AOP is congruent to triangle AOS. That means these two angles are equal. How do you name that angle? Okay, we'll do one thing. Name all the angles. This angle is 1, this can be 2, this can be 3, this can be 4, this can be 5, this is 6, this is 7, and this is 8. So we just named it randomly. 1, 2. Okay, so this triangle AOP is congruent to AOS. That means angle 1 is equal to angle 8, relation number 1. Similarly, we can prove that in triangle BOP and triangle BOQ. This is equal to this. BP is equal to BQ. Tangents. OP is equal to OQ. Radii. And OB equal to OB common. That means triangle BOP is congruent to triangle BOQ. BOP is congruent to triangle BOQ. That means angle 2 is equal to angle 3. Angle 2 is equal to angle 3. Similarly, what we can prove that is, I'll take these two triangles. Triangle ROD or DOR and triangle SOD. We can write that RD is equal to this, that you can write these two are equal tangents, these two are radii, and this is common. Therefore triangle ROD is congruent to triangle SOD. Angle 6 is equal to angle 7. Similarly, we can prove the remaining these two triangles congruent, and angle 5 is equal to angle 4. This can be written as 3, and this can be taken as relation number 4. When you add 1 plus 2 plus 3 plus 4, we will get angle 1 plus angle 2 plus angle, okay, let us leave it that. What happens when you add all, we have to prove that it's supplementary. What happens when you add all these, add all these angles, angle 1 plus angle 2 plus angle 3, you write A, 1, 2, 3 rather than A, B, C, D. It will be 3-letter words, it will be 3-letter angle, it will be difficult. Angle 4 plus angle 5 plus angle 6 plus angle 7 is equal to 360, total angle at the center of the circle. But what is angle 1 plus angle 2 plus angle 3 is same as angle 2 plus angle 2. So this is done. The substitution is done for angle 3 plus angle 4 is same as angle 5. So angle 4 is same as angle 5 plus angle 5. That is this angle. This is written as 4 plus angle 6 plus angle 7 is rewritten as angle 6. So these are the changes. What is the rewritten? I have just changed the color. This is equal to 360. So when you look at this, angle 1 plus angle 2, something is missing. Oh, I forgot to angle 7 plus angle 8. This also should be equal. This angle 8 can be rewritten as angle 8 is same as angle 1. So what happens is that angle 1 and angle 1, 2 times angle 1 plus angle 2, 2 times angle 2 plus angle 5 plus angle 6, and 2 times angle 5 plus 2 times angle 6 is equal to 360 degree. 2 times angle 1 plus angle 2 plus angle 5 plus angle 6 is equal to 360. Implies angle 1 plus angle 2 plus angle 5 plus angle 6 is equal to 180 degree. Let us look at this angle. Angle 1 and 2. 1 and 2 is this angle. Plus 5 and 6. 5 and 6 means this angle. So that is equal to, that means angle 1 and 2, we got this. AOB plus DOC. Angle AOB plus angle DOC is equal to 180 degree. Implies angle AOB and angle DOC are what? Are supplementary angles. Supplementary angles. Similarly, now when you substitute this angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 is equal to 360 degree. 360. Out of that, we have few angles, which are that angle 1 plus 2 plus 5 plus 6 is equal to how much? Is equal to 180. If we substitute that over here, what we get is that angle 3 plus angle 4 plus angle 7 plus angle 8 plus all these things will be equal to 180. That is equal to 360 degree. That means angle 3 plus angle 4 plus angle 7 plus angle 8 is equal to 360 minus 180. 180. What are 3 and 4? When you look at 3 and 4, you can see BOC. BOC. Angle BOC. This is angle BOC plus angle 7 and 8. 7 and 8 forms AOD. Angle AOD. That is equal to 180 degree. That means those angles are also supplementary angles. Now, so that's with the reader questions, exercise question. We will do one more important question from the book, that is a solved example. Let us take the question. Let the kid. Two tangents are drawn to a circle. We don't know whether the this figure is a part of a question or not. It's an important question. Two tangents TP and TQ are drawn to a circle with center O. Let us do without the figure. I mean, figure is not given in the part of the question. We will draw the figure and try. Two tangents TP and TQ are drawn to a circle with center O. O. TP. TP and TQ. TQ. Center. Prove that angle TPTQ. This angle is equal to PTQ. This angle is equal to 2 times OPQ. OPQ. So this angle OPQ, this angle is equal to PTQ is equal to 2 times OPQ. So in given, you have to write given circle. I mean, TP and TQ are the tangents drawn to given circle. Prove that this is equal to 2 times this. To prove that angle PTQ is 2 times angle OPQ. So let us take this angle as theta. Let angle PTQ is equal to theta. Now when you look at this triangle, what you can see this, in triangle, we know that TP is equal to TQ. Why? Tangents drawn from external point. Tangents drawn from external point. You write that, tangents drawn from external point. Therefore, triangle TPQ is what? Isosceles triangle. Therefore, angle Q is equal to angle P. Not the complete angle, I mean these two angles are equal. Let us take it as X. So this is X and this is X. Now, in triangle TPQ, we have theta plus x is equal to 180 degree. That means theta plus 2x is equal to 180 degree, or 2x is equal to 180 minus theta implies x is equal divided throughout by 2. 180 by 2 minus theta by 2, that is 90 minus theta by 2. 90 minus theta by 2. But what is angle? What is, okay, now what is angle? This entire angle. Angle TPO is equal to 90 degree. What is the reason? Tangent is perpendicular to radii. Okay, that means what is angle? That means we can do TPQ, that means x plus angle OPQ. X plus angle OPQ is equal to 90 degree, or angle OPQ is equal to 90 minus x. What is 90 minus? What is x actually? What is x actually? Substituting that over there. 90 minus theta by 2. When you open the bracket, 90 minus or minus theta by 2, that is equal to theta by 2. So we get that angle OPQ is equal to theta by 2. Theta by 2. When you cross multiply this, 2 times angle OPQ is equal to theta. What is theta actually? Theta is PTQ. That is angle PTQ. This is what we have been asked to. Angle PTQ is equal to 2 times angle OPQ. This is what we've been asked to prove. So we take that, we take this angle as theta, and using isosceles property, x and x are equal to x. Angle sum property, you will get that x is equal to 90 minus theta by 2. Again, now you look at this, you can see that this angle is 90. X plus the required angle. This is what you have been asked to prove. We have been asked to prove that 2 times OPQ, x plus that is equal to 90 degree. X plus that is equal to 90 degree. So that particular angle is 90 minus x. Or we substitute the x which we have already found out. Substitute. So you will get 90 minus 90 minus, so theta by 2. So when you cross multiply, you get that. That's with that question. Okay, now we will do the additional question separately for this. Okay, so go through the concepts and be thorough with the reader question.